Graphing linear inequalities in two variables. So first off, let's start with an example. Negative x plus 2y is greater than or equal to 4. The easiest way to do this is kind of to treat it like you were graphing an mx plus b y equals line. So the first thing you want to do is solve for y. To do that, same steps as if we had an equal sign instead of a inequality symbol. The difference comes with inequalities when we divide negatives, and we'll get into that as we do examples. So, dividing by 2, I get y is greater than or equal to 1/2 x plus 2 as my equation. Getting my coordinate system ready. Y-intercept of 2, so I'm going to come up 2. Slope of 1/2 means from this point I'm going to go up 1 over 2, up 1 over 2, and I have this equation for this line. So here comes the difference. I now have this line drawn, but the solutions that work are anything equal to, which makes it a solid line, or greater than this line. So there's two ways to do this. You can either test a point to see which side to shade on, or you can think about greater than is above, less than is below. Let's test a point just so you can see this. Typically I'll pick 0, 0 if it's not on the line because it's an easy point to test. So I throw 0 in for y, and I throw 0 in for x. And all I'm going to see is it a true statement? So 0 times this goes away, and I ask myself, is 2 less than 0? No, false. So this point 0, 0 made a false statement, which means the other side of the line would make true statements, and that's what I should shade. Think about this. If I want y values that are bigger than this line, I want y values above this line. So we would be shading above it anyway. Doing a second example, say we were given 3x minus y is less than 6. Subtract 3x to both sides. I get negative y is less than negative 3x plus 6. Divide by negative 1. And y is greater than, so when we divide by a negative, it flips the symbol. Divided by negative 1, flip the symbol. Negative 3 divided by negative 1 gives us 3x. 6 divided by negative 1 is negative 6. Graphing this line, xy coordinate system. Let's get some scale on there. 1, 2, 3, 4, 5, 6. So we start at negative 6, so 1, 2, 3, 4, 5, 6, starting down here. Then we go up 3 over 1 is how you can think about it. So up 3 over 1, up 3 over 1, and it would continue this same pattern for forever. So we have the starting line, but here's something to note, which I've already made a slight goof. If I don't have the equals bar below it, I don't make a solid line. So what my line should be is dashed. If I wasn't in pen, I would use my eraser at this point to erase chunks of the line, but we'll make the purple our final line. Then, I want y values above the line. Above the line is over here. A way to show that would work with testing points, let's test the point 0, 0. So here's our test point. So 0 greater than 3 times 0 minus 6. Is 0 bigger than negative 6? Is that a true statement? No. Or excuse me, yes. Yes. Since it is a true statement on this side, that's the side that we shade on.